Welcome to The Explainer. Today, we're diving into a massive breaking story in AI news. We are officially crossing the threshold into the era of highly capable autonomous AI agents. But here is the wild part. The latest absolute bombshell in this space didn't come from some Silicon Valley tech giant. No, it came from a city government in Brazil. We're going to unpack how IplanRIO just released a massive open-weight model that is completely rewriting the rules. And of course, we'll explore the incredible underlying engine that made it all possible, Alibaba's Qwen 3.5. Here is a quick look at our roadmap. We'll start with the AI agent arms race, move into the efficiency of sparse architecture, check out some native multimodal reasoning, and wrap up with the open weight ripple effect. All right, let's anchor this whole conversation on a really striking quote from Mark Einstein over at Counterpoint Research. He recently told CNBC that if AI agents truly take off, they could, and I quote, upend traditional internet business models. Think about the massive economic and geopolitical stakes here. We're not just talking about a slightly faster search engine anymore. We're talking about fundamentally altering how digital work actually gets done. And the democratization of these open-weight models, it means that immense power isn't just locked up by a few tech billionaires. It's trickling down, which sets the perfect stage for the wild municipal deployment we're going to look at today. But real quick, before we get too deep into the technical weeds, let's make sure we are all completely on the same page. What actually is an AI agent? Well, unlike a standard large language model where you type in a prompt and just get text back, an AI agent is a system that can independently take action. It can complete multi-step tasks on your behalf, using tools, searching the web, writing code, executing that code, all with almost no supervision from you. It's basically the difference between having a really smart encyclopedia and having a digital intern. Section 1. The AI Agent Arms Race. Just look at how fast the industry has sprinted forward in a matter of weeks. We saw Anthropic drop new agent tools that absolutely rocked the software-as-a-service market. Then, right on the eve of the Chinese New Year, Alibaba launched Qwen 3.5, releasing both open-weight and hosted versions. At the exact same time, Chinese competitors like ByteDance and Zhipu AI pushed major upgrades to their own agentic models. Meanwhile, over in the US, OpenAI scooped up the creator of the super popular open-source agent framework OpenClaw. The entire global tech industry is quite literally sprinting in the exact same direction right now. Section 2. Efficiency through sparse architecture. Now check out this staggering contrast in the numbers. Qwen 3.5 boasts a massive 397 billion total parameters. But to generate a single response, what developers call a forward pass, it only actually activates 17 billion of them. This right here is the absolute brilliance of the mixture of experts, or MOE architecture. Think of it like a giant iceberg. The vast majority of the model's total knowledge is submerged and dormant, and only the specific expert parameters needed to answer your exact prompt are activated at the surface. It optimizes speed and cuts costs dramatically without sacrificing any of that frontier-level capability. And the proof is really in the pudding when you look at the results. These are self-reported benchmarks straight from Alibaba's technical docs, comparing their open-weight Qwen 3.5 against some of the most expensive, proprietary closed models in the world, namely GPT 5.2 and Claude 4.5 Opus. On hardcore STEM reasoning with GPQA, Qwen 3.5 scores an 88.4, holding its own beautifully. But look at visual math reasoning via Math Vista. It actually scores a 90.3, beating the closed models outright. The fact that an open-weight, highly sparse model is matching or beating the heavyweights is a massive threshold moment. And as we're going to see in just a minute, this is just the baseline engine. So how exactly did they pull this off? Beyond the MOE sparsity, they utilize something called gated delta networks. Essentially, these are highly specialized attention networks that keep the AI laser-focused on the task at hand without hallucinating. They also built an FP8 pipeline. Without getting too bogged down in the math, that's a streamlined data processing method that literally cuts activation memory usage in half. It makes training so much faster and cheaper. Plus, the model naturally supports 201 different languages and dialects. Oh, and if you use their hosted version via Model Studio, you get a 1 million token context window. To put that into perspective, that means you can feed the agent up to 2 hours of raw video at a single time. Section 3. Native multimodal reasoning. Okay, let's look at how this model actually thinks. This is a fascinating real-world example taken right from the documentation. The AI was fed a sequence of video from a UK dashboard camera and asked to explain a highly dynamic outcome. Why exactly didn't the car stop at the intersection when the traffic light turned amber? The AI didn't just mindlessly label a car and a traffic light. It actually performed complex, multi-step logical deduction. Step 1, it identified from the early frames that the approach light was green. Step 2, it pinpointed that the light flipped to amber exactly as the vehicle hit the advanced stop line, which it recognized by a painted bicycle symbol on the road. Step 3, it deduced that given the car's proximity and speed, slamming on the brakes would be physically dangerous. So Step 4, it concluded that under UK traffic laws, proceeding through the amber light in this exact point of no return scenario was legally valid and safe. That is the kind of robust spatial and temporal reasoning you absolutely need for embodied AI and autonomous driving. Here's another really cool one testing spatial intelligence. It's a visual puzzle of a 6x6 parking lot. The AI is shown the image and given a prompt. All vehicles can only drive forwards or backwards. The black car wants to leave the garage. What is the minimum number of gray vehicles that need to move? So what does the model do? It perfectly maps the entire 6x6 grid in its mind's eye, identifying the length and physical constraints of every single vehicle. It starts at the exit and works backward. It realizes, okay, the middle bus is blocking the black car. But to move the middle bus down, the bottom bus has to move left. To move the bottom bus left, the bottom left car has to move up. And to move that car up, the left truck has to move up first. It flawlessly traces this entire chain reaction to conclude that exactly 4 gray vehicles need to move. It's just a brilliant display of multi-step spatial planning. Section 4. The open weight ripple effect. 403 billion. Now, that is not just some arbitrary figure. That is the total parameter count of a brand new, community-driven model known as Rio 3.5 Open 397B. And this brings us to the massive paradigm shift that is currently shaking up the entire AI ecosystem. This incredible new model wasn't created by a trillion-dollar tech conglomerate. It was created by IplanRIO, the tech arm for the city government of Rio de Janeiro. You know, we usually expect government tech to move at a snail's pace, but they completely bypassed the traditional bottlenecks. They took the open Qwen 3.5 engine we've been talking about, merged it with another model called Nexon 2 Pro, and then refined it using a technique called on-policy distillation, which basically means they had a smarter teacher model tutor it. The end result? A fine-tuned MOE model that actually outperforms Qwen 3.7 Plus on key benchmarks. And the best part? They hosted it completely open on Hugging Face for the entire world to use. Which brings us right back full circle to the question we started with. When a local city government in Brazil can spin up an autonomous, frontier-level AI agent by brilliantly merging open-source weights, what happens to traditional internet business models? We are moving at absolute light speed from a world where we sit at a keyboard and search for information to a world where we casually deploy highly capable agents to just go execute tasks for us. The technology is here, the weights are open, and this arms race is very, very real. Thanks for joining me on this explainer, and I want to leave you with this. How are these open-weight agentic systems going to completely transform your own day-to-day workflows?